Okay, well, it's 10 o'clock. We can go ahead and get started. Thank you all for joining us for another edition of the Long Coffee Break. My name is Bill Rohn. I'm a senior sales engineer with Long. And today we are going to be talking about high efficiency frost-free energy recovery. We are lucky enough to be joined by Rob Jones, regional sales manager with TEMPEFF. Thanks, Rob. With that, I'll hand it over to you.
Thanks, Bill. Good morning, everyone. Today we're going to be talking about TEMPEFF's dual core technology. So TEMPEFF is a semi-custom to custom air handling unit manufacturer that has an ERV capability. To totally understand what dual core is and the advantages of it, we're just going to do a quick review of conventional technologies. Some common types that are out there. The first one is a plate type heat exchanger. This is very common in residential applications. The pros of it is it's a relatively low capital cost. It has no to low cross leakage, and it has few moving parts, so maintenance is okay. The cons, it has relative low sensible recovery of 40 to 60%, and that's without taking frost into account. And you're going to hear me talk a lot about frost and defrost strategy today. Okay, it has a significant frost buildup problem. It requires a preheat or a defrost strategy, and that adds complexity and cost to your design. You'll hear me ask you this, and it's just something I want you to think about, but does it make sense to add heat to recover heat? Okay, due to the tight construction of the air flutes, it does require periodic cleaning, as we know that dirty exchangers are less efficient exchangers. Probably the most common out there is the heat wheel, relatively high sensible recovery of 50 to 75%. It also can provide latent recovery. So energy wheels do come with a desiccant coating. The cons, it has a significant frost buildup problem, and this is very particular to energy wheels where a preheat or defrost strategy is required to protect that desiccant coating that is on the cold side of the exchanger. Big moving part, higher maintenance. Okay, this wheel requires a belt to drive it, and of course an additional actuator. Once again, due to the tight construction, especially around the flutes, it's easy for dirt and debris to build up on the wheels, causing them to be less efficient. Manufacturers will actually combat this by having a filter before and after the wheel. This drives up your pressure drop, size of your fans, and your energy consumption. The more related to the energy wheels is they have a lower life cycle of some of them they have to be replaced after 5 years due to the damage to the desiccant coating. Not very common anymore is the heat pipe style. We've seen these in operating rooms and clean rooms. They have moderate sensible recovery of 45 to 60%. They have no cross leakage, and that's why they're used in clean rooms. The cons of them, significant frost buildup problem, absolutely requires a defrost strategy, a higher relative cost, and no latent recovery. It also contains a refrigerant, so there is a risk of a leak. In summary, conventional technologies have lower effectiveness of 40 to 75%. Frost. When the heat recovery devices are needed the most, these conventional technologies are the least efficient. Okay, adding heat to a job adds complexity and cost. And I'll ask you again, does it make sense to add heat to recover heat? So what is dual core and what's the difference? In its very simplest form, this is the heartbeat of our unit. We have an exhaust or return fan, a supply fan, 2 aluminum energy cores, and a damper changeover section in the center. This is it in its simplest form. The energy cores are made up of aluminum. We do it in a cassette style fashion, and it's directly related to the amount of CFM that is going through the unit. This cassette in the middle is the biggest one we make. It's 60 pounds. That's a service person with work gloves. Okay, not hundreds of pounds like heat wheels can be. Corrugated aluminum, and we take every second sheet and we flip it. It creates a very haphazard or random pattern. This is for 2 purposes. Is 1, larger air flutes, so dirt and debris do not become a factor. And 2, this causes air turbulence. And when the air is tumbling through our heat exchangers, it makes it easier for the aluminum to scrub out and retain that energy. It has 2 recovery phases. In recovery phase 1, we see here that the exhaust or return air is coming back from the building. You can see the dampers are in a horizontal configuration. The air is moved over, the exhaust air is moved over to energy core A, which is actively scrubbing out and retaining that energy. It's charging, and then it's exhausted to the outside atmosphere. Over here, the cold outdoor air is coming through energy core B that is already charged. The air is being warmed over to the supply air and into the building. It will do this for exactly 60 seconds, and 60 seconds is the key here. That is when our units are the most efficient at 60 seconds, and it guarantees us that we can maintain cross leakage at 1 to 3%, which covers the first 3 classes of air for ASHRAE 62. After 60 seconds, the damper will flip and is now in a vertical arrangement. You can see the exhaust air is now doing a U-turn and going through energy core B. Energy core B is now recharging. Over on the other side, the outdoor air is now shifted and coming through energy core A before doing a U-turn to the supply air and into the building. So what does this mean for you in Denver? That if the outdoor air is -10, is that the supply air, when it leaves our unit, will be somewhere between 64 and 66 Fahrenheit. Very easy to get it up to 72 after that, and all you're doing is reusing the building's energy and running a couple fans. This is it in action. So what we see here is the return air coming back. It's being directed over to the energy core A, and energy core A is gradually warming up over that 60-second cycle. Down on the other side is we have the outdoor air coming through the pre-charged energy core B being warmed and into the supply air. And of course, once the cores are expended, the dampers will shift, and now it does the U-turn configuration. Energy units can be too efficient, especially in the shoulder seasons. So we do offer standard with all our units is a free cooling or bypass mode. This is where we stop energy recovery due to the fact that the exhaust air set point and the supply air set point, our temperatures are above set point. So we no longer are required to do energy recovery. So the exhaust air is just shot through the unit and out to the outside atmosphere, while the outdoor air is shot directly into the supply air. It will do this up to 3 hours before it will direct the air the other way, and that's so that the cores can self-clean themselves. Just like our 60-second cycle, every time it switches, it blows off any dirt or debris that's been captured on the face of our heat exchangers. So they literally self-clean themselves. We also have a recirculation mode as well. This is for low occupancy or no occupancy of the building, where the building energy, whether cooling or heating, is being returned right back to the supply air. So again, there's no energy recovery going on. What we do here is we slightly crack open our shutoff dampers. This creates a positive pressure around the damper and a negative pressure across our 2 cores. That means that that air, that energy, will naturally migrate to our cores and charge them. This gives us the ability to do a morning warm-up cycle if the unit is shut down to prevent a cold blast of air when the unit first fires up. You would do this 15 minutes prior to the building being occupied. The cores are charged and ready to go. We also have a shutoff mode, so if the unit is completely off, we'll configure our dampers to isolate the building from the outside atmosphere. These are all standard features. So what are the advantages? High temperature efficiency. We are rated at 90% sensible recovery in the wintertime and 80% in the summer. Frost. Unlike other devices, we do not require a defrost strategy. Okay, high latent recovery is with our dual core product is we offer 70% latent recovery in the winter, and with our dual core plus product, okay, we can offer 60% latent recovery in the summertime. How we do this is all on the principle of thermal mass. And this is why we don't need a defrost strategy, is that our cores are 39 inches long. When the outdoor air is coming through our heat exchangers, is they get moved to the warm side, not giving frost a chance to form. Any droplets that are there, large droplets, will drop through our heat exchangers into a drain pan and out to the building drainage system. Any humidity mist that's created is picked up in the next recovery cycle and blown into the building, adding latent recovery. And that is standard with all our dual core units. Okay, there's two things people will not complain about in the wintertime. When you're bringing out outdoor air, they never complain that it smells too fresh in the building. And when you're bringing in latent recovery, they never complain that their skin feels good in the winter. We have low maintenance. Our cores are stationary, only our dampers move. They're self-cleaning, and if necessary, such as a casino application where smoking is allowed, our cores can be easily pulled out, no bolts or screws, hit with a pressure washer, cleaned up, dried off, and inserted back in, complete. This is what the internal control section looks like. You have your damper arms here that are controlling the damper that's in behind, along with the actuator. And we have our Schneider PLC controller with the BMS connections in the bottom here. We also have a manual and auto switch. So if there is no BMS system, the Schneider controller will run our unit. It works in both standalone mode and with a BMS system. Obviously, all our products are BACnet capable. This is it in action. That is an electric actuator. It fully opens or fully closes in less than a second. Pneumatic actuators are about a second. Standard features of our unit. Recirculation mode is built right in on all units. It's standard. Indoor units are an aluminum post and panel construction. This gives us the ability to build them into sections so that you can easily move them into a building. You quickly just slide them together and then bolt them, and you're complete. Our outdoor units are frameless, but they can also be built into section for ease of craning. This gives us the ability to add the gasket in the field, slide them together, bolt them together, and you're done, reducing your crane capacity. Our standard is 24 galvanized steel. We can do any gauge steel if you want. We can do stainless steel. We can do marine grade aluminum, whatever you wish. The reason why we can use 24 gal is we use a foam injection process in all our panels. This makes them extremely rigid with a higher R value. Hinge doors throughout for easiest servicing. Electric actuators are standard, and the damper section can be used as shut-off dampers, which you saw. Excuse me. Options. Our standard blowers are direct drive phantom fans. We can also do belt driven, even though it's not very common, and we could do multiple fans and ECM fan arrays. Our standard starters and VFDs are Danfoss or ABB, but we can use other people's jobs if you need to create other people's products, if you need to have a standardization throughout a job. Single point power is an option on 90% of our jobs. It's single point power. Multi-point power is not commonly used anymore. We can make them into package units. So for heating, we offer hot water, electric, direct and indirect gas burners. And on the cooling side, chilled water or DX coils. We use high efficiency filters. Our standard is MERV 10, but we do all the way up to HEPA filter. You name it, we can get it. Special coatings, powder, epoxy, Harrisite, enamel, painted panels with a salt spray. We're very good at knowing what coatings to use in certain applications. You can always consult with us. Pneumatic actuators for Class 1 Div 1 applications. We can also include the compressed air system within a service vestibule in all our units. Storm louvers and inlet heads are obviously is an option that we have. So in summary, high temperature efficiency. We're 90% sensible in the summer and 80% in the winter. Okay, zero frost. This is the big takeaway. Is we don't require a preheat or defrost strategy in normal conditions. And normal conditions to us is -40 with a 25% relative humidity. Okay, this is our jobs that we have in Northern Canada and the Arctic. High latent recovery of up to 70% with dual core in the winter and with dual core plus 60% in the summertime. Lower maintenance, we're self-cleaning. Excuse me. We have self-cleaning, but the cores can be easily taken out. Long-term performance, we did a third-party study on a 17-year-old installation. It was still running at 90% like day one, and our core warranties are 10 years. They're made out of aluminum. They're hard to break. And with that, I hope I gave you some good insight on what our dual core technology can do. I thank you all for your time, and I'll turn it back to you, Bill.
Thanks, Rob. I really appreciate it. Thank you all for joining us on this coffee break. Please reach out to your Long sales engineer for additional information on TEMPEFF. And now it's time for giving out prizes. This week's prize choices are a $100 Bass Pro gift shop card, bottle of baking soda, and a Coach Tech organizer. Reach out to your Long sales engineer for your prize. Thank you again for joining us. Have a great day.